I hope you can hear us well. And it's my pleasure to welcome you here on today's webinar about hackers' fingerprints. My name is Tomáš Sárocký, and I'm here with my colleague Jindřich Dudek, who's our ethical hacker, who's an expert in the hacking activities. And he prepared a wonderful scenario for us today. But Jindřich, can you tell us more a little bit about what you prepared?
So hello guys, as Thomas already mentioned, my name is Jindřich, and for today I've prepared a presentation that consists of two parts. In the first part, I would like to show you advanced security incident, network security incident, which focuses on stealing of the user's private data. And in the second part, I would like to show you how the Flowmon solution can help you with investigation of such a scenario.
Sounds good to me. I'm looking forward to what you prepared for us.
Okay, when I was creating this demonstration, I was inspired by the series of attacks that actually happened in the Eastern Europe and that were called Dark Vishnia. These attacks was kind of interesting because the attacker was able to physically enter the building of the company that he chose as his victim. He was dressed as a delivery man or as a job applicant, and when he was left in the guest room, he was able to hit a small device under the desk and connect it to the local network and to his command and control server. And since that time, he was completely able to scan entire network, brute force some services, attack the vulnerable services, and stuff like that. So now let's try to imagine that we face the situation I just described and that we have a parasite device in our network, right?
So someone was on a job interview, came to the, I don't know, printer and put something in the USB port.
Yeah,
for example.
and to the network as well.
Right.
All right. So now for this purpose, I've created a virtual environment that will represent our network that consists of 3 devices. The Ubuntu machine will represent our victim that will be target of our attacks. Then there is a Kali, which is Kali Linux, that will represent our attacker, our hidden secret device. And then there is a pfSense, which is a router, which serves as a default gateway for the machines Kali and Ubuntu, which basically means that all the internet traffic that originates from the victim or from the attacker is going through this pfSense machine, right? So now what we want to do as an attacker, the first thing we want to do is to redirect the network traffic from the default gateway to the machine of the attacker, so we can read and manipulate the traffic that victim sends, and then forward it to the original default gateway. So there are basically many approaches how to do that, but we are going to misuse the DHCP protocol, Thomas, today.
All right. I'm interested how we are going to use this.
Okay, so DHCP protocol is a protocol that is used for automatic assignment of the IP addresses and other network communication parameters that are required for communication in the network. So to clarify how we will redirect the traffic, let's take a look how the usual DHCP process works, right? This process usually is performed when a new device connects to the network, which means when you plug in the Ethernet cable, or for example, when you connect to the Wi-Fi, right? So when you connect a device to the network, the newly connected device, usually first packet that is sent is called DHCP discover, which basically means something like, hello, is there any DHCP server in this network? that could assign me a network parameters, right? And this message or this packet is sent to all the devices in the network, right? So usually devices where there is no DHCP server running, it just simply ignores this message. And the DHCP server responds with a packet that is called DHCP offer. In this packet, the DHCP server offers an IP address to the newly connected device and other network communication parameters, which is the IP address of a default gateway and usually the IP address of the DNS server, right? And this message is directly sent to a newly connected device. Now, because there may be generally more DHCP servers in the network, it is necessary to say which parameters the newly connected device chose, right? So for usually the newly connected device accepts the first offer that it receives. So for this purpose, the DHCP request is sent to inform all the devices in the network which IP address was chosen and which network parameters. So the newly connected device sends the DHCP request, and when the DHCP server receives this packet, the DHCP acknowledgement is sent in a response to inform, okay, you can assign these parameters, right? And since this time, the newly connected device has assigned IP address of the default gateway and IP address of a DNS server, actually.
So all the details about the network and its connection.
And all the network parameters that it needs to communicate. All right. So now let's take a look at the DHCP spoofing attack, which is the attack that is used to redirect the traffic. And let's take a look what we can do as an attacker to perform that. All right. So again, when a newly connected device is connected to the network, the DHCP discover packet is sent. Attacker can pretend that he's a regular DHCP server, and he can send his own DHCP offer, and he offers to the victim any IP address, and then what is important, he sets his own IP address as the IP address of a default gateway, which means all the packets to the internet sent to me, to the attacker, and also IP address of a DNS server optionally, and he can also set this IP address to his IP address. Okay, when the newly connected device receives this DHCP offer, it again sends a DHCP request to the attacker, because the newly connected device has no idea that it is not legitimate DHCP server. All right, and now the attacker sends just the DHCP acknowledgement, and the newly connected device configures IP address and all the parameters to itself. All right, and now when the legitimate DHCP server sends a DHCP offer, the newly connected device just ignores that, because it has already assigned IP address from the attacker, right?
That sounds very interesting. So what does the attacker has to do in order to perform this DHCP spoofing attack?
Basically, the only thing you gotta do is to be quicker than the legitimate DHCP server, but it should not be that problem that much, because usually your device will have more computing power than actually some kind of router or any device. So you should be faster. You can, so you can be faster. So
understand. So it's pretty simple then to perform this kind of attack. Just a faster device you need.
Yeah. So now enough of theory, and let's take a look how it can be done practically, right? So, all right. So to set our fake DHCP server, I am going to use the tool etocap. So I'm going to run this tool, and here we choose unified sniffing. And now let's use the HTTP spoofing. Okay, the first thing we have to fill in is the range of IP addresses that will be assigned to our to newly connected device in the networks, right? To avoid conflicts with already existing devices, it is necessary to set this range so there is no collision between this range and already existing devices. So what we can do is scan the network now to see which devices are present in our network already. So let's start a tool called Nmap, which will scan network for us.
That's just a simple tool for port scanning.
Yeah, and as you can see, there are two devices, which is our pfSense router and our station of the attacker. All right, so IP address of the router ends with 1.1, and our IP address ends with 1.100. All right, so now let's choose any IP range where there is no conflict. So let's set something like this, for example. Now we have to fill in the net mask, which we'll obtain from the ifconfig command, and it is this value. So I will just copy this value and paste it here. And now we should set the IP address of a DNS server, right? So this this we will set to the IP address of the attacker.
Right, because the attacker wants to be the DNS server.
Yeah, we want to see which domains the victim tries to enter and possibly manipulate the answers for the DNS queries, actually.
Right.
All right, so now if the victim connects, the only thing we would cause is a denial of service attack, because our operating system is not ready yet to forward the packets that does not belong to the attacker. So when the victim sends any packet that is not for the attacker, the packet will be just dropped by the attacker right now. So what we got to do now is to enable the packet forwarding. So I have prepared a script for this. All right, now you can see that the packet forwarding was enabled. And you can also see that the utility DNSChef was executed. DNSChef is just a simple DNS proxy. And the only thing it does is that it listens for the incoming DNS queries and forwards them to the real DNS server. And prints out to the console which domains the victim tries to access, right? But there is just one exception, and the exception is facebook.com. When the victim tries to access the facebook.com domain, this IP address will be returned as a result of a DNS query. So surprisingly, this is the IP address of the attacker, right?
Surprise, surprise.
So when the victim tries to access facebook.com domain, it will be redirected to the attacker's machine. But we are not Facebook server, right? So
no, we are the attacker.
Yeah. So what we need to do now is to run a phishing page of a Facebook at our machine, so we can pretend that we are actually Facebook, right? So for this purpose, I'm gonna use a tool that is called Black Eye. As you can see, there are many pages that you can phish with this tool, but we are going to choose Facebook, right? All right, so let's choose Facebook. And now everything is ready for our victim to connect, hopefully. So now let's simulate the connection of the victim.
Right, so this is the victim booting up the device.
Yeah, exactly.
Basically, connecting to the network.
Yeah.
In other words.
Yeah. So as you can see, the victim's machine tries to boot up.
That is probably some old machine, right?
Yeah, free virtual machine at one computer, it's not very easy for my laptop. All right, so you can see that the victim is really booting up. All right. And now let's try to switch back to the attacker's machine. And as you can see in the console, there are already some DNS queries from the victim, so which means that the traffic redirection should be successful because we can see the DNS queries of the victim, right? So when we take a look at the output of the ettercap tool, you can see the following. The victim sends the HTTP discover, then we sent a fake offer, and we offered the first IP address from the range I've said before. Then you can see that the victim requested this IP address, and that the attacker actually acknowledged this request. And here you can see the DHCP offer from the legitimate DHCP server, but it is just ignored. So there is no more responses for this offer.
So this is basically just the showcase of the explanation which you did a few minutes ago.
That's the proof that I didn't lie. All right, so now let's switch to the machine of the victim, and let's open the internet browser. It will take a while, maybe.
It looks like it's working, so the victim is there. All right, so just to check the internet connectivity, let's, for example, try to enter the flowmon.com domain just to make sure that the internet connection is working. Yeah, it looks like it is working. Yeah, and it's already loading. So yeah, everything works just fine. Yeah. All right. So flowmon.com domain was properly loaded. As you can see, there is an icon of padlock, which means that the connection is secure. So all the internet traffic goes to the attacker, but this connection is encrypted. So the attacker cannot see anything, even though the communication is goes to through his machine. All right. So what we need to do now is just wait until the victim tries to access the flowmon.com domain, right? So now, in Facebook.
Yeah.
Probably. Right, so probably there is a lunch break or something, and the person is not working. So yeah, let's
check our Facebook, right?
Private time and check the Facebook updates.
So we are going to facebook.com domain, and now I'm going to switch back to the attacker's machine, and here you can see that really the victim tries to access facebook.com domain, and that our attacker sends back his IP address as a Facebook server. All right, so let's switch back to the victim's machine.
And pretty good to me, not like an attacker.
Yeah, and we can see basically the login page of Facebook. Is there anything strange, Thomas, for you at this page?
Well, it looks pretty legitimate. Probably me as bit security concerned person, I would notice that the connection is not secured on the top left side, but as a standard user, wouldn't notice.
Let's be honest, who checks this? Yeah. All right, so there is written no secure, which basically means that the connection between you and this page is not encrypted. So every information you provide to this page will be sent unencrypted, and the attacker will be able to read this. All right. So now let's enter our mail address, and as a password, I will choose simply password. All right. And now I submitted the form, and then I redirected the victim to the legitimate facebook.com domain, right? So as you can see, here is the icon of padlock, and we're just redirected to the authenticated session of the user that was authenticated before.
So basically, the standard user would not notice anything because would just log in, and even if the password is incorrect, it would be redirected and everything works.
Yes, exactly. And now let's take a look what we can see at the attacker's machine, actually. So when we take a look here, we can see here that the victim with this IP address connected to our phishing page, that it uses a Chrome browser, actually, with this version. And here we can see his credentials or the credentials of the victim in a plain text. So we have successfully stolen the credentials for Facebook of the victim, right?
Wow.
So now we can take an advantage of the fact that usually people share the same credentials between more services.
Yeah, unfortunately, that's the fact, which, as we all know, should not be the case, and we should use unique passwords for each service.
Yeah, but we can misuse it now, so it's good for us. So now again, let's scan the network and take a look at the services that are running at the machines in the network. All right. So again, we are using nmap to do so. And as you can see, there is again our router pfSense. There is a DNS resolver running, which does a translation of domain names to IP addresses, basically sends response to the DNS queries. And then we have some web pages here. Then there is our victim and our station. Our station is not very interesting for us, but as you can see, there is a SSH service running at the victim's machine. SSH is protocol, Thomas, that is used for remote management of the device. So you can use the SSH protocol to remotely log in to your device, and then you can remotely execute commands there. Usually commands with privileges of the user that you're logged as, actually.
So I would assume that by default this should not be allowed.
Yeah, it should not be allowed in a public places, probably.
Right.
All right, so now let's try to connect to the SSH service using the credentials that we obtained from the Facebook. So we are going to use the username we obtained. Now we are going to write the IP address of the victim, and we are going to use a password as a password. And as you can see, Thomas, it is not our password we are looking for.
Well, this user probably was a bit more careful about the
sharing credentials.
Yes.
Yeah.
Using the same password in multiple services.
Yeah, but when you see how simple the password for Facebook is, we could expect that the password for this service can be simple as well. So for this purpose, I prepared a list of 500 worst passwords that are used in the world. And as you can see, it's a simple text file with one password per line. And we can use a dictionary attack for this, which is the attack that uses this pre-built list and tries all the combination of of username and passwords in this file. So we are going to use a tool called Hydra for this. So as a login, we are going to use notender. As a passwords, we will use the file I've just shown. And we are going to attack SSH protocol and add this IP address. Okay. So now we can enjoy this very interesting output of the Hydra tool. It just simply says which combination of login and password it tries. So we just have to wait for a while, and if we will be lucky, there will be maybe our password.
Hopefully, because the user was not clever enough to use a stronger password for Facebook account, so possibly there would be similar simple password for SSH service as well.
Yeah, and as you can see, the tool was able to find the proper password, and it's almost the same, but with 1, 2, 3 at the end of the password.
So a little bit more advanced, but still not good enough.
Yeah. So okay, let's now try to log again to the SSH service. And now we're at the device of the victim, basically. So every command I will run here will be performed at the victim's machine, actually. So for this purpose, Thomas, I've already uploaded an archive with a script to the anonfiles.com upload site.
Okay.
And I will get a downloadable link, and I will download it by utility called wget at the victim's machine. So what I'm doing now is that I uploaded an archive, and I try to download it to the station of the victim.
Right.
So okay,
Works.
As you can see, the archive was downloaded. We are now going to unpack it. Okay, we are going to download it again. So yeah, I'm going to upload this again because the archive was probably broken. Yeah, and now we were able to successfully unpack this archive. So as you can see, there is a script and there is some kind of file.
Right.
So now I'm going to run this script with the file as a parameter. All right. So I've run the script right now, and let's now remove all the traces we left here. All right, so now as you can see, everything is deleted and we can successfully disconnect. And now everything is ready for the highlight of this presentation, which is the tool SSL split. But to understand how the SSL split works, I'm going to switch back to my presentation and let's take a look at how the negotiation of encrypted session usually works. So the connection is usually initiated by the client, and the client sends some kind of packet to the server, and it says something like, "Hello, I need to establish an encrypted connection, and then the server responds with another packet. That they exchange some packets with some parameters that are necessary to negotiate the encrypted session. And as a result of this negotiation, they will establish a common shared encryption key that is used for encrypting and decrypting messages. So now, when the client tries to send a request, it will use the shared key. It will use the shared key to encrypt that and send it to the server. And server uses the same key to decrypt the request, read it, and send an encrypted response. Right?
Standard communication.
Yeah, that's how it usually works. And now let's take a look what the SSL split tool does. Okay, because we have a traffic redirected to the machine of our attacker, the attacker is able to detect that the victim tries to access the legitimate server. So what the attacker basically does, that he does not forward the packet to the legitimate server, but instead he establishes the connection by himself. So he pretends to the server that he's legitimate client and establish a connection with him. So the attacker communicates with the server responds, and as a result, they both share a key for encrypting and decrypting the traffic. All right. So now, when there is the established connection between the attacker and the legitimate server, the attacker finishes negotiation with the client, but to the client he pretends that he's a server actually.
Right.
So he responds like a server, and he establishes a connection with him as well. So okay, now we have two established connections between the attacker and the legitimate server, where the attacker pretends that he's client, and between the attacker and the victim, where the attacker pretends that he's a server, right?
Okay.
And now, when the victim sends any packet, the attacker owns the necessary keys that are required to read the message and re-encrypt that and send it to the server. All right, and similarly, when the server sends a response back, again, the attacker is able to decrypt that and send back a re-encrypted response.
So the attacker is basically the man in the middle.
Yeah, this attack is called man in the middle. So
all right.
He can read every communication between the server and the client. If now we are getting to the part why I executed the script.
Yes, that's why I'm interested, because you did something and I was not sure what was that.
So why I did that was because if I didn't do that, you would probably see in your browser this warning that you're probably familiar with. Every time you try to access any domain with your browser. It is because when the client tries to communicate with the server usually tries to prove that he's the legitimate server that the client tries to communicate with. And this is done by sending a certificate. So the server sends a certificate that is signed by certificate authority that is trusted by the browser, right? So the browser has the list of trusted certificate issuers, and these issuers just signed the certificate for the domain. And when the client receives the certificate, the browser ensures that it is really trusted, and then he will load you a page. But our attacker does not have a certificate that is signed signed by a trusted certificate authority, right? And he cannot even use the certificate of the legitimate server, because these certificates usually contain the parameters that are specific for the server. So the attacker cannot use this certificate. So what the attacker does basically is that he generates his own certificate authority. And what I did, that I took the certificate of this certificate authority and I inserted it to the trusted store of the Google Chrome browser, which made him trusted.
Right. So that was the downloading the zip file, uploading it to the victim's device.
Yeah, exactly. So so this was the way how we made the attacker's certificate trusted by the internet browser. So now, when we switch to the attacker's machine, and we run the SSL split tool, now let's switch to the victim's machine.
Right, there is still the Facebook.
Yeah, and now let's, for example, go to the seznam.com domain, which is a domain of the one of the largest Czech free mail providers.
Yes,
so
very popular
domain.
in Czech Republic.
Yeah,
I believe almost everyone in Czech Republic knows.
Yeah, and this site cannot be reached. Yeah, this may happen actually. It is because sometimes there is a problem with SSL split or with the internet connectivity. So let's restart the SSL split.
Right, we can really see that it is a live demo, that it is happening right now.
Yeah, this sometimes happens. So just for sure, let's reset all the scripts that we have run. And just for sure, let's reopen the Google Chrome browser. It's maybe caused because there is some kind of bug in the SSL split, and sometimes it just does not want to work. Maybe now we'll be more lucky.
Well, looks okay.
No. All right, but it doesn't matter very much. I think that we would spend a lot of time. I will try it one more time, maybe.
Give it a try.
Let's start with Google. Yeah, it does not work. Well, it doesn't matter. I can show the rest of the presentation from the video that I made for these cases. So it doesn't matter very much. So wait a minute, guys. So so we will move to the part with SSL split. So we run the SSL split tool, and now we will switch to the victim, and we will enter the domain seznam.cz. As you can see, there is an icon of padlock in the left top corner,
which shows that it is secured, right?
Yeah. And when we take a look at the details of the certificate, we can see that there are some strange values in the certificate issuer. like the datathieves.com and stuff like that. I chose these values just for the demonstrational purposes because the because the attacker would probably use something more sophisticated. All right, so now we are going to try to log in to email page at the sesnam.com domain. And let's enter some credentials.
Right, we want to log in, we want to check our emails there.
Yeah.
We want to see.
Yeah. And this account actually does not exist, but it's not that important. But what I can show you here in a live version, finally, I will try it one more time with our victim, but I'm not sure if it will work. Yeah, I don't know why is this happening. But when we take a look into the log file of the SSL split tool, and we will look for some keywords like password, you can see that there is a password in a plain text, even though the session was encrypted, even though that yeah, the session was encrypted. So basically, the attacker, since this time, may see all your encrypted communication. So, like your credentials, like your bank accounts, like your Facebook messages, basically everything, without any notice by the victim.
That is thanks to the man in the middle or the SSL split tool.
Yeah, exactly. So. Okay. So this is all from the practical part of the demonstration. I'm deeply sorry for the SSL split issues. I'm not really sure why this is happening. When we tried this before, it never happened. So I don't know. Basically, maybe some kind of internet connectivity issues. I don't know. And now,
the interesting part, right? What we can actually see out of this in Flowmon.
Yeah. So let's take a look what we can see at the Flowmon. Okay. So now I am in the Flowmon ADS module, which is a module that is used basically for anomaly detection from the flow data, actually. So as you can see, now we are at the dashboard when there are some charts with a brief overview of events that were detected during performing this live demonstration. Here you can see the events, but what we want to see is a detailed view on the events.
Right, we want to see the details about what has happened and what Flowmon can actually show us.
Yeah,
this kind of attack.
So let's hit the search button. And now here we can see some events that were detected. The first one is a DHCP anom with this IP address, which is IP address of the attacker. And we can see that the fake DHCP server was detected in the network, which is true because the attacker really pretended that he is the DHCP server. Then there is another event, which is called DNS anomaly, which says that there was an unauthorized DNS server used, and it was used by this IP address, which is our victim, and the server has this IP address, which is again our attacker. Then there were some scans because we scanned the network to see which devices and which services there are in the network. And here you can see ARP scan, which purpose is to detect the active device in the network. You can see that there were two responses, which is the router and the victim. Again, you can see that there was a vertical TCP SYN scan, which is a scan that is used to find services that are running on the devices in the network.
Right.
Here you can see that these two devices were scanned, which is again our router and our victim. And then you can see two events, SSH dict and dict attack, which basically says the same. Again, the source of both events is the attacker. The target is the victim. And basically, these two events says the same, but they use a different approach how to detect dictionary attacks on various services.
Okay.
And the SSH dict method can also determine whether the attack was successful. Yeah, you can see in the detail that the attack was actually successful. Right. So now we can, for example, take a look at the event evidence, which is the list of flows that are evidence for the detected event. And here you can see that the victim queried the facebook.com domain.
Right.
Okay, so to see more detailed information, we can also go to the Flowman Monitoring Center and take a look at the raw flow data. So we can see more detailed information. So here I will choose Analysis.
Right, but the difference between ADS and the monitoring center is that here we have to do it manually.
Yeah.
And we have to search for it.
Yeah, the purpose of anomaly detection system is to automatically detect the anomalies, and then you can use Flowman Monitoring Center to see the raw flow data.
Right, for forensics, for example.
Yeah, for forensics. Okay, so when we take a look at the events, they pretty copy the structure of our attack, right? So now let's take a look at the DHCP traffic. So here I will choose list of flows, and here we will choose output DHCP, so we can see DHCP data. And then in the filter, I will use my prepared filter for the DHCP communication, and then I will choose process. All right, and here we can see that really there is a DHCP communication with the source IP address, which is the attacker. And here we can see the offered IP address. So we can see that the attacker really offered this IP address. And when we take a look here at this event, that there was an unauthorized DNS server used, we can see that there is this IP address, so the attacker was probably successful. All right, now let's take a look at, according to our structure, to another raw flow data, and it will be the DNS communication of the victim. So we will choose DNS, and I will again use my prepared filter for DNS traffic, and let's hit process. And as you can see, the victim really communicated with the attacker and queried him for facebook.com domain, which can be seen here. And then we can take a look at the response, and in the response there is this IP address. So this is the private address. So probably the attacker responds with this IP address as a result of a DNS query, and redirected the victim to the attacker station. Okay, so now we can see that the victim tried to access the facebook.com domain. So probably it communicated using the HTTP or HTTPS protocol.
Right.
So let's take a look at the HTTP communication of the victim. So again, I'm going to use my filter HTTP victims HTTP communication, and I will maybe choose to display more flows than 20 and sort them by the start time of the flow. And as you can see, really victim communicated using the HTTP protocol with the attacker. Here you can see that the victim requested some Cascade style sheet files, some JavaScript files, and here you can see that there is a login.php, and it was submitted by post method, which can say us that really the victim submitted some kind of credentials to this page. So from this, we can probably expect that the Facebook credentials of the victim were compromised. Okay, now let's take a look at how it is possible to detect the man-in-the-middle attack, right? So
that's a little bit harder, and we haven't seen it in the
that's a little bit harder, yeah, but I will try to show you how we could find out that, for example. So now I've switched to the statistics section, and I choose that I want to display HTTP host name. And let's take a look at the HTTP host that the attacker communicated with. So let's take a look at it. And here we can see that the attacker communicated with Facebook, with Seznam pages, Google.com, unknown files, and stuff like that. And when we take a look at the communication of the victim, you can see that is pretty similar to each other. So the attacker communicated with the similar domains as the victim. This is the first thing that can show us that there may be probably the man-in-the-middle attack.
So basically, two stations have the same communication to the internet.
Yeah. And what we can do now is that we will display the communication between the victim or first between the attacker and between the login page of Seznam. So it will take a few seconds. And here we can see that really the attacker communicated with Seznam login page. Here you can see some details from the TLS protocol. Here you can see the issuer of the certificate, which is a known issuer. Here you can see the validity of the certificate, some algorithms that was used during the session negotiation, version of the TLS, offered cipher suits, and stuff like that. There are a lot of information, and here you can see the setup time, how long it took to establish a session. Okay, and when we take a look at the same thing from the point of victim, you can see that also it communicated with login page of Seznam, but there is a strange TLS issuer of the certificate. So
Right.
It is really strange that one domain would use two certificates to authenticate to the client actually. And what we can do as well is that we can take a look at how many certificates were used for the domain sysnam.com. So what we are going to use, that we aggregate HTTP hostname and the issuer of the certificate. And it will be for domain, for example, www.sysnam.cz. And as you can see, for this domain, two certificate issuers were used. So this is strange, and this should not happen. So that's the way how it is possible to, for example, see that there was a man-in-the-middle attack was performed in the network.
Right. That's a wonderful example which you showed us, how we can actually see this to check those certificate issuing authorities.
Yeah. So that's all for my demonstration.
Wonderful. Great. Thank you very much. So to summarize it, basically we got you explained us about the DHCP spoofing attack and how we can do that over there, how we can set up DNS proxying, how we can run dictionary attack, get access to SSH service. So
Yeah.
so we could import the certificate and then run SSL split tool.
Yeah.
By which we can actually steal any data from any web browsing the victim is actually doing.
Yeah, there are more tools than just SSL split, but I use SSL split because it's command line tool and it's most easy for me to use.
Right, obviously.
But he disappointed me today.
No problem. That sometimes happens. So, and at the end, you showed us what everything we can see out of this attack in Flowmon, whether it's going to be ADS or the monitoring center. Well, I suppose that it is a great example of use of Flowmon. I hope you all liked it. We spent an hour together watching what everything can be done as an attacker or as an administrator, security administrator, while securing our network. Hope you liked it, and don't worry, this webinar was recorded, and we will make sure that within following weeks we will remake it, make it beautiful video, and share it with you. So looking forward, and stay in touch with us for other future webinars. Thank you very much, and have a nice day.
Thank you.